Okay guys, today's lesson is on page 33. We are going to be talking about substitution. So we're still in that lesson 3.1, but we are talking about substitution. So if we look at the top up here, it's still talking about our situation with the supply and demand. But this one's saying investors try to control the level of risk in their portfolios by diversifying their investments. You can solve some investment problems by writing and solving systems of equations. One algebraic method for solving is called substitution. Now, most of you probably remember this from Algebra 1. Some of you may not, so that's why we are going back over this. Now, in example A, it says during 1 year, Sarah invested $5,000 into two separate funds, one earning 2% and another earning 5% annual interest. The interest Sarah earned is $205. How much money did she invest in each fund? Step 1, let X represent the money in the first fund and Y the money in the second fund. So, you write your equations out. She knows that both funds are going to total $5,000. And then she's got her interest rates. So 2%, 5%, that's the total money that she got in interest. So what we're going to do when we substitute, the first thing that you're doing is you need to isolate a variable. And it doesn't matter whether it's X or whether it's Y, but you're really trying to find somebody that's going to be easy to isolate. So they chose equation number 1, and they're isolating Y. So they had to get rid of X, so you can see they subtracted X. Now that they have equation 1 isolated, you substitute that into equation 2 right there for Y. Because that's who you solved. That's who you isolated, so you plug it in. Then you just do the math. You can see they did their math. They solved for X. So X equals $1,500. So what they do is they substitute that back into either the first or the second equation. It's not going to matter. They chose the first just because it's going to be easier. Plugged in $1,500. And then they solved for Y by subtracting $1,500. So now they know that their investment was $1,500 in the first fund, $3,500 in the second fund. Okay, so let me work out some so that you can see me showing my work, and we can go from there. Okay, so here we go with A. If I look at A and the state that it's in, I have two equations. One equation, two equation. The first equation has already got X isolated. So all I need to do is plug it into equation 2 for X. So instead of writing X, I'm going to write open parentheses, 25 minus 3Y, close parentheses, plus 5Y equals 9. Then I'm going to distribute. Like so, 25 times 4 is 100, minus 12y plus 5y equals 9. So I'm just solving this mathematically. Over here, these are on the same side, so I'm going to combine my like terms. That gives me -7, I believe, but I'm going to use my calculator just to double check. Yep, -7y. Bring down the 100, bring down the 9. I need to get Y by itself, so I subtract 100 because it's positive. So do the opposite operation, bring down -7Y. 9 minus 100 is -91. Divide by -7. Y, hold on, let me divide by -7, equals +13. Now, that's only part of the solution because remember, what we're really looking for is their point of intersection. So we're trying to figure out where exactly they're going to intersect. So I need to plug that back in. I'm going to plug it back into the first equation. So X equals 25 minus 3, and instead of y, I'm plugging in or substituting in 13. 25 is going to be done in a second. The first thing I'm going to do is multiply negative 3 times 13, which gives me negative 39. So I've got 25 minus 39, which gives me negative 14. So my solution is negative 14, comma 13. Now, if I wanted to know if I had done that correctly, you would then do a check, okay? Checks are optional. It's really just up to you. But if you're going to do a check, you plug that into both of the equations to make sure that they both check out. So this one is going to be negative 14 over here, negative 14 over there. So that one checks. We got that one. Now for the second equation, I plug in my negative 14 for x. I plug in my 13 for y equals 9. So I'm going to plug that in my calculator. This gives me negative 56. That gives me 65. Okay, so negative 56 plus 65 gives me positive 9, which is exactly what it's supposed to give me, so it checks. So you know 100% you got the correct answer for B. Okay, you can pause that if you need to copy that down, but I'm going to continue and go on to B. For B, okay, I've got two equations. The first one has no one isolated. Okay, it's got x and y both on the same side. On the second equation, we almost have y isolated. But if we isolate y, we're going to give ourselves a fraction, which is okay. So I'm going to go ahead and embrace that so that you can see me work with a fraction. When I divide that, 2, that's going to leave me with y equals x divided by 2, or 1/2 x minus 5. So this is now equation 2. I'm taking that equation 2 and I'm plugging it into equation 1 for y. So I have x plus 2. Instead of y, I'm plugging in 1/2 x, minus 5. Okay, so then I distribute. What's half of 2? Well, that's 1, or just x. 2 times negative 5 is negative 10. Wait, I didn't finish this. Equals 14. Sorry. Bring down this x, bring down equals 14. Combine your like terms right there. 2x minus 10 equals 14. Add 10. 2x equals 24. Divide by 2. Divide by 2. So x equals 12. Again, that is only half of the work. Then you can plug into either equation 1 or equation 2. I am going to use this equation 2 because y is isolated. So I'm going to plug in 12 for x. So 1/2 times 12 is 6. 6 minus 5 is 1. So y equals 1, which means my answer is 12, 1. Okay, again, pause that if you need to. For C, okay, on C, neither one is isolated. Not the first equation or the second equation. So I just have to choose who I want to isolate. Doesn't really matter. I'm going to choose equation 1, and I'm going to solve for y. So if I'm going to solve for y, that means I'm going to add x. So y equals 4 plus x, or x plus 4. Either way, it doesn't matter. This is still equation number 1. You take that equation number 1 and you plug it into equation 2. So we have 3x plus, instead of y, I'm plugging in 4 plus x. You can put that in parentheses, but in this case we don't have to because there's not a number in front of y. It's like 1y. So it'd be like distributing a 1, which is going to change nothing. So that really just drops the parentheses and you don't have parentheses. You combine like terms that are on the same side. That gives us 4x plus 4 equals 16. Subtract 4. 4x equals 12. Divide by 4. X equals 3. That's the x. To get the y, you have to plug back in. I'm going to come to this y here, the one that I isolated. Say y equals 4 plus 3. So y equals 7. If you are unsure or you want to check, remember that you're plugging that into both the top and the bottom equations. Okay? D says Eli invested a total of $2,000 in 2 stocks. One stock cost $18.50 per stock and the other was $10.40 per stock. Eli bought a total of 130 stocks. Write an equation write and solve a system of equations to represent this. So we're going to have 2 equations here. We're going to have one that represents the cost and one that represents the total shares. Okay, I'm going to start with that total shares. You've got 2 different types of shares, and they are going to equal 130 because she says she has a total of 130 shares. Then we're going to talk about the cost. One of them costs $18.50 per share plus $10.40 times the other share, and it equals $2,000. Okay, so you set up your equation, and then again, the first thing that you're going to do is isolate. I am going to isolate equation 2, and I'm going to isolate x this time, so I'm going to subtract y. So x equals 130 minus y. That's equation 2. So I plug equation 2 into equation 1 for x. So I've got 18.5, and instead of x, I'm plugging in 130 minus y plus 10.4y equals 2,000. I then distribute, which is going to be 18.5 times 130. That gives me 2,405. And then I have minus 18.5y plus 10.4y equals 2,000. So I'm going to combine my like terms. I've got negative 18.5 plus 10.4, and that gives me negative 8.1y. Bring down my 2,405 equals 2,000. I'm going to subtract 2,405 from both sides. So I get negative 8.1y equals negative 405. Divide by negative 8.1. And y equals 405 divided by negative 8.1. Positive 50. Sorry, positive 50. So that means that they had a total of 50 of the second shares, okay, of the y shares. So 50 of the y shares, which means how many of the other shares do they have? Well, to find that out, I simply take that, plug in 50, 130 minus 50 is 80. 80 shares of the other type. Okay? All right, let's take a look at our next page. If we look at the next page, number 11 says, when using substitution, how do you decide which variable to isolate and which equation to solve? It doesn't matter. It really does not matter. You could choose either x or y in either equation. What I would say that you need to do is look for a variable without a coefficient. I think that's right, coefficient. Okay, and if you can find one without a coefficient, choose that one. Doesn't matter if it's the first equation or the second equation. Don't worry about submitting this for your homework. Just submit that previous page, page 33. Okay, so for your notes today, I want you to take a picture of your page 33 and everything that we did. Or like if you needed to use a loose leaf sheet of paper because I just showed so much work, do that for page 33. Submit your notes. Once you've submitted your notes, go and do Delta Math. All right, I hope y'all have a great day, a great weekend. I will see y'all next week.